In our last couple of videos, we looked at some function operations. We looked at addition, subtraction, multiplication, and division, and then we looked at composition of functions. In this video, we're going to look at an application of operations on functions, specifically subtraction and division. And we're going to see that we're going to be using a formula, f of x plus h minus f of x all over h. And this is actually an application of slope for a curve, and it's used in calculus primarily. But we're going to see how to evaluate a difference quotient using this function, or excuse me, this formula. And we're going to see that it's really a matter of finding each of the pieces of the formula and then putting them in and then simplifying. This formula, it's called the difference quotient because of the subtraction, which is the difference, and then the division, which is division, the quotient. And we're saying that we have two different values of y in the numerator, the difference of two values of y, and then we have the difference of two values of x in the denominator. But for our purposes in college algebra, we're just going to evaluate this formula for a given function. So let's say that I'm given the function f of x equals 3x plus 7. And what I want to do is find the difference quotient for this given function. So when I say find the difference quotient, that means evaluate that function in this formula. And notice here that the minus sign in the formula and the division line and the h are all just part of the formula. We're just going to put in literally a minus sign, a division line, and an h when we get ready to evaluate this. We are given the function, f of x. That's just our function that we have here, f of x. So really the only thing that we don't know here, the only thing that we don't already have is the f of x plus h. So we're going to do this in a couple of steps. And our first step is going to be to evaluate f of x plus h. And remember when we learned in our lesson about finding function values that the f tells us where we're plugging in, and the x plus h, the thing in the parenthesis, tells me what I'm replacing x with in. H, that so this is 3 times x plus h plus the 7. And I can distribute that 3. And there's really no combining that I'm going to be able to do here. I'm not going to be able to combine like terms. So what I've done here is I have found f of x plus h. And I see that for this function is 3x plus 3h plus 7. That is going to replace the f of x plus h in the difference quotient formula. So now I'm going to plug everything into the formula, the difference quotient formula. So in place of the f of x plus h, I'm going to put 3x plus 3h plus 7. And then I have my minus sign that's part of the formula here. And then I have my f of x, just plain old f of x, this piece, which is 3x plus 7. And because I'm subtracting, I need to put a parenthesis around that. I'm subtracting that whole thing. And then the rest of the formula is just the division line and the over h. So what I have here is that this is equal to 3x plus 3h plus 7 minus, and I'm going to distribute the negative to both of those terms, all over h. And now I can combine like terms. And notice I have 3x minus 3x. That cancels out. 3h doesn't have anything to combine with. And then 7 minus 7 cancels out. So the numerator is just 3h and the denominator is h. And then my h over h cancels, and that's equal to 3. So what I found here is that the difference quotient, f of x plus h minus f of x all over h, for the function f of x equals 3x plus 7 is just equal to 3. And that ties into what I said earlier about that the difference quotient is actually a slope formula. And notice 3, we haven't actually talked about this in this class yet, we will very soon. 3 is the slope of that function. Let's try another one. Let's say that I want to evaluate the difference quotient f of x plus h minus f of x all over h, and I'm just writing the formula here, for the function f of x equals negative 2x squared plus x minus 11. So we're going to do the same thing that we did before. Our first step is going to be to find f of x plus h. And we're going to do that separately before we start trying to plug into the difference quotient formula. And remember that when we are finding a function value, we're replacing x in the f function with whatever's in this parentheses, in this case x plus h. So we have minus 2 times x plus h squared plus x plus h minus 11. So x plus h, the thing in the parentheses, replaced the x everywhere there's an x in the f function. So now we're going to evaluate that. The first thing I need to do by my order of operations is square the x plus h. So I'm going to go separately here, kind of off in the margin here. And remember, x plus h squared means x plus h times x plus h. So if I FOIL that out, I get x times x is x squared, x times h is xh, h times x is also xh, and then h times h is h squared. And I can combine the two xh's to get plus 2xh plus h squared. So all of this, x squared plus 2xh plus h squared, replaces x plus h squared because it's the same thing. And then I can just distribute, and here's just a plus 1. So it's plus x plus h minus 11. And then finally, I can distribute my negative 2. oops, I'm distributing a negative. So I have minus 4xh minus 2h squared, and then the plus x plus h minus 11 just drops down. Now this looks crazy. This doesn't look like something that you might recognize. But when we're doing a difference quotient, we're going to see that we're going to have something that looks like this, with x squareds and xh's and h's and x's and h's and numbers. And nothing is really going to combine. Nothing is going to simplify like terms. But remember, all we're doing at this step is finding just f of x plus h. We haven't done the difference quotient yet. So my next step, got some old notes here. Let's delete those, or clear those. So our next step is just going to be to put all of this in for, I'm going to go ahead and rewrite the formula here so we can see it. So what we're going to do here is we're going to put all of this in place of f of x plus h. So we have negative 2x squared minus 4xh minus 2h squared plus x plus h minus 11. And then we have subtraction here, minus f of x. And I have to put parentheses because of that subtraction, which was minus 2x squared plus x minus 11. And then over, all over h. And I have plugged everything in to the appropriate spot. And let me just give you a note here. Please, 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 once you have found your f of x plus h, don't just try to put the minus sign and subtract the f of x and do it in that same step. Because when we have this chain of equal signs, we have that f of x plus h equals this, equals this, equals this. And if you start trying to put different things on there, the minus sign and the f of x plus h, it's no longer just f of x plus h, and you're going to confuse yourself. So to keep straight what you're doing, actually rewrite out all of f of x plus h, subtract, rewrite the function all over h. And then you can distribute the negative. All of this just recopies. So then I just distribute the negative and I get plus 2x squared minus x plus 11 all over h. And then I can combine like terms and cancel. And I'm going to have you go ahead and pause the video, combine the like terms in the numerator, and then cancel the h in each resulting term. I want you to try that on your own. Pause the video and then restart the video. All right, so we see minus 2x squared plus 2x squared cancels. Minus 4xh doesn't have anything to combine with. Minus 2h squared doesn't have anything to combine with. Plus x minus x cancels. Plus h doesn't have anything to combine with. And then minus 11 plus 11 cancels. And notice that every single term in f of x canceled. That's the same thing that happened on our previous example. Every single term in f of x canceled. And that will happen every time that you do a difference quotient. So every single term in f of x will cancel, and every single term that you are left with, we still have over h, is going to have an h in it. So if I think about how this works with this h in the denominator, if I broke this up into separate pieces here, this is the same thing. That h is dividing every single term in the numerator. And so this h cancels an h in every one of these terms. So my h cancels here, and I get negative 4x. One of my h's cancels here, and I get minus 2h. And be careful about this one. H over h, when that cancels, I'm left with plus 1. So what we've done here is we have evaluated the difference quotient for this function, and my result is negative 4x minus 2h plus 1. And at this point in college algebra, that's not going to mean much for us, but if any of you are going to end up taking calculus or survey of calculus for business majors, you'll learn more in that class about how to go forward from here.